Hello there, I'm Malcolm Bidden,
And I'm Daren Fulwell.
and we are the Network Freestylers. Today's episode is Freestyle 110, designing for SD1. Well, I was going to say SD1, but I'm going to say SDN. My head's in SD1 at the moment, so that's why where I was going with that. But yeah, so today we're going to talk about designing for SDN. So this is probably going to be a bit higher level than normal, more sort of like pre-sales, high-level design, architectural design, some of the things to consider about designing for SDN, and I think some of the building blocks. But Daren, you've put a bit of an agenda together today, and if you want to flick to that, there it is. So do you want to give a bit of an overview and then jump into the SDN recap?
Yeah, no trouble.
What, where, why, when?
Yeah. So that's, like you say, the idea with this one came really because, well, SDNs are everywhere, right? It's not just in the WAN, and it's not just in the data center. It's in the campus and throughout there. People are using them for all kinds of things. So there's a number of ideas, I guess, that we had about the general approach to it. There are a lot of things that are similar regardless of where you're building your SDN, I guess. So what I wanted to do was just cover some of those. So, like you say, we'll have a quick recap of SDN and the approach, and then what we'll do is we'll go a little bit further into the elements of SDN and the design that you need to consider when you're approaching those elements. So, right, just bear with me a second while I switch across.
Your magic pen.
So SDN, let's take this from the top, okay? And I'm going to go way back a little bit further than that. So forgive me if I'm going to hopefully not send you to sleep, but I wanted to set some context, okay?
You might actually see before you jump into it. We've not rehearsed this, by the way, people. So you might actually cover this, Daren. But before you jump into that, what was the first SDN solution that you heard of, and what was the first one that you deployed?
That's a really interesting question. I mean, I suppose OpenStack and was the kind of first well-known, kind of developed from university research projects, and hopefully.
Did you hear about that in the buzz at the time, or or was it just something that was? I think it's in the background.
I think it's something that was happening in the background, and that as SDN solutions become more mainstream, so people sort of picked up on some of the history and where it come from. As is all these things, right? It's often good to sort of learn about the history of something in order to fully appreciate where it's come from, where it's going to, and how it's come about as part of this design process, right? And so I guess my first experiences of actually deploying any of this stuff were with Cisco ACI when it first reared its head in the end of 2014, early 2015. So
I mean, for me it was obviously done it to death on some of the videos, but the first actual solution I'd heard of was IWAN, so Cisco IWAN, and then obviously some of the competitors around that time. The main competitors were Silver Peak, I think, had a SD-WAN solution, and there was another couple as well. So SD-WAN, and then past that it was like sorry, not SD-WAN, IWAN and ACI. So the APIC EM aspect of IWAN, which didn't actually work very well unless it was a greenfield, but it was still sort of paving the way. And then ACI from the data center perspective, and other than that, you heard of basically the competitors in the WAN and the data center space. But yeah, working in mainly Cisco shops and Cisco integrators, it was IWAN, which evolved into VIP. Then I started hearing about Viptela and then ACI. And it wasn't until I'd done my first IWAN deployment that I actually started understanding about how ACI might work. And then it was another couple of years until I actually done anything with ACI as well. So yeah.
So of
Cool,
course you
that's
had,
interesting. Yeah.
yeah, no, but I mean you had other solutions as well in there, weren't there? Things like OTV for data center interconnect and Lisp for used in conjunction with OTV as a DCI technology, which had elements of the SDN in them, I suppose, centralized control plane and things like that. But we'll come to some of that. But I think that those ideas and those concepts, I mean, hell, GRE tunnels of DMVPN, all of those things have elements of what we now call SDN. So is SDN just a marketing term? Possibly, but I mean, it does sort of package up a number of capabilities into a term that's of use, hopefully, to us, at least to describe a generalized approach to doing networks.
Yeah.
Which kind of leads straight into really how I wanted to sort of to cover this. Now you'll notice I'm doing this on a blackboard rather than a whiteboard today. I'm trying this out, so we'll see how it works. See if it looks like chalk. Just trying to be trendy. Sorry. So
that'll be a light board next week.
yeah, that's it. Yeah, with the green screen and all the rest of it. Yeah, absolutely. They're always a bit weird though. Have you noticed? Because when you're looking at the people, they're actually reversed. But that's another story. No, I mean let's break this down, right? So, what's the point of a network? A network is there, right, to take your endpoints, whatever they are, your laptops and your handhelds and what have you, to connect those through to something servers that are providing access to applications, right? So this is a really dodgy picture of an application and a pointer running on a screen over there. Those applications obviously need access to databases and the such like in order to get anything. And often that data comes either from those endpoints that have already drawn there or possibly sensors and the such like. So maybe a temperature sensor or it may be used, you may have light bulbs and home automation systems or whatever attached to your network. Okay. So there's an interaction required between all these elements. You'll catch up with me in a minute where I'm going with this, so bear with me a little bit. In order to bring all those things together, you've obviously got some LAN infrastructure, lots of switches, and you might have a bit of a core distribution access thing going on over here. So there's lots of interconnections. You've got some wireless maybe. You've got some obviously physical wires and everything at the edges there. You'll have potentially some WAN in the middle here. You'll have sitting out in your data centers, you might have a couple of sets of switches like so. In one data center, you might have another one in another data center, and then you'll have these guys and some servers connected to do that, and everything interconnected. Quite a complex environment when you look at it like that, right? There's lots of moving parts and lots of things that need to be connected together to make this stuff happen. And application developers didn't make this any easier for us network types, right? We had to pull all kinds of jiggery pokery to make this stuff work. So you've got your endpoints, your apps, and your data. But we had to do things like, I don't know, we have to worry about the layer 2 connectivity in these locations. And that means the dreaded spanning tree, of course. We'd have to think about, well, if we need some resilience or we need failover or we need traffic flows between those two data centers, we need to think about DCI connections, data center interconnects. we need to think about, okay, failover going into the wide area network. How's that going to work? How does it work within the sites and then without? So we're thinking about the routing protocols and about the way all that works. We're considering how we interconnect the servers and the trunking and the port channels and all that sort of good stuff. So there's failover and resilience that we need to consider. And this all leads to a mess of complex configuration. You know, these things are not easy to put together because they're all different types of networks. We need to document that because someone's got to support that. And somehow, when it comes to making changes in this environment, we have to manage that end-to-end sort of change control. Okay.
Not break anything.
And not break anything, because you know, you've got, let's say you've got this app, the laptop up here. There we go. This guy up here is accessing this application here, and you need to change this switch right in the middle here. How the heck are you going to be sure that you're not, you're making a change there and it's not going to impact that traffic flow? It might not do, but it might do. And it's the complexity of this that's the problem, right?
Mm-hmm.
We get rid of those. So the other things, I got a couple of other points as well, because obviously what you need to think about here is the security of the environment, and that's from all levels, right? That's worrying about the endpoints and whether they can see each other, but whether they're safe from threat elsewhere. And you've got to do everything you can to minimize the size of those failure domains. If you've got a situation where one of those elements, if it dies, can take out the whole lot, you've got a bit of an operational nightmare, right, to try and deal with. And don't we know about that? As network guys, we know all about operational nightmares.
Mm-hmm.
So SDN comes along and offers us the opportunity for some kind of solution to this thing. And I'm going to generalize. I'm not looking at a specific product here because I want to illustrate this. But the idea with an SDN approach is to kind of layer and tier the architecture so that you're able to separate out the levels of complexity and reduce that operational issue, really, to minimize the issues with that the operational guys will face in dealing with the network. And the fix to that, or the big fix, if you like, the headline one, is to create the idea of the virtual network. Now, the idea with the virtual network is that it doesn't matter where you are on this network, it doesn't matter what you're connected to, that you can see the things that you need to, and that you can't see the things that you don't need to, and that the endpoints and the applications and the databases and whatever else, all of those things see the network they're expecting to see. Now, part of the problem back in the day was that an application developer would always expect his application to be sitting on a LAN, and so wasn't built to understand that there are certain complexities to overlaying that application across a wide area network. Nothing much really changed. It's just the WANs got faster and bigger and more resilient. So there's still those sorts of requirements there that applications and endpoints and data expect to see each other in a certain way on the network, i.e. with an IP address, connected to an Ethernet port or whatever. So SDN allows us to effectively virtualize this network and turn it into a single thing, right? So you can effectively, see if my pen's going to work. Here we go. You can effectively color all that out and say, yeah, this is just one big network, and it will function in such a way that you just connect to the network and you get what features you need. Now, The way it does that is uses the existing network that we already had as an underlay. Okay, so I'm going to draw that in a little layered thing up here. So we have our underlay network, and this is the same network that we always had before. In a WAN sense, this can be an MPLS network or the internet or whatever. It doesn't matter, so long as the elements at the edge of that that network can talk to each other. It doesn't matter what that is. In a LAN sense, it might be routed network, spine leaf in a data center, or even an arbitrary type topology in a campus. It almost doesn't matter so long as that network is built to support the rest of the environment.
So in the LAN on the campus end, Darren, and
yes,
the data center, this would have to be a rooted environment. So where we're used to having like a distribution layer as the layer 3 demarcation, and then loads of downstream layer 2 links to access switches, that would need to be layer 3.
It can be, yeah. I mean that's the beauty of it. You're not concerned about worrying about where the layer 2 is and where it's not. In as far as the SDN's concerned, so long as those devices that sit at the edge, let me this sort of jumps ahead a little, but so long as these devices at the edge of that SDN can see the other ones at the other edge, what goes in between doesn't actually matter. It's just transport. But we'll come to that in a bit more detail in the next slide. But yeah, sure. let's play on with that. So the idea is that you have this underlay, this fast, quick network that converges like a normal one. That's built to allow those devices at the edge to talk to each other. You then, so that's your underlay. You then have what's called an overlay to sit over the top of it, predictably. Now that overlay effectively is another layer of transport that normalizes the underlay. So it's typically tunnels between the edge devices, though not always. And what that allows you to do is abstract away whatever the underlay transport network is, so that it looks the same to all of the edge devices, whether it's internet and IPsec over internet, whether it's just an MPLS network, whether it's a 4G mobile, whether it's a line of sight microwave, whatever it is, to those end devices, it just looks the same. And you're able to.
I mean, one of the things I never really thought about it like this before. I've probably subconsciously thought about it, but if I was to describe underlay and overlay then in a few words, underlay in respect to the concepts of the two, the underlay is really, even though it's like the traditional network where all the complex routing and all that took place previously, that would now become more of like, instead of lots of dynamic state changing all the time and lots of it, it becomes a very little amount of state and
absolutely
and absolutely rock solid. Obviously the internet might not be rock solid, but in general terms it is. I mean, from a state perspective, there should be minimal change other than adding new segments on the network, and then all that dynamic state, does that move up a level into the overlay?
Exactly that. So what you're doing there is all that transport, all that underlay is there to do, is to provide the connectivity between those edge points on the underlay. So it's just that point of saying, right, okay, you could literally, and this was one of the points I'll make later, but I'll remake it again shortly. You can literally just use that underlay network to take loopback addresses from all of the devices around the edge of the network, and route between them. So sounds a bit like MPLS, right? And the way PEs might work. But what you're not having to do is carry all the state of the customer networks, the virtual networks that sit on the top, because that's just tunneled over the top, and the interaction for that layer of state is elsewhere. Okay.
Yeah. So in summary, underlay stable, very little state, overlay dynamic, lots of state.
Yeah, and we're going to add another layer of state to that as well, because what you then do once you've created the overlay, which, like I say, may be a mesh of tunnels or similar, which sit across the top. What you then have typically is the creation of virtual networks that sit on top of those. The beauty of that is that you can use a single set of transport and a single set of overlays to provide multiple virtual networks across the whole of your SDN environment. Now, you might think, well, why would you want to do that? Well, let's just think about in our example here. What we might do is we might create a virtual network here, which is for IoT devices, which gives the IoT devices that opportunity to send data back to a database. Okay, so these guys here might be connected in some shape or form into the pink network, which delivers data to back to that database at the back end. You might then create another one, which would be for your corporate traffic, corporate application traffic. So your PCs and your mobile devices can connect to that and connect to the application server. And then the application server at the back end can also join the IoT device, the IoT network. So it can, or have a separate connection so it can pull data back from the database. So you're able to provide separation, even though you've got the same sets of underlays and the same set of overlay. You can provide two completely isolated networks across that same. I'll use the word fabric, but that's more of a marketing term than anything. So it gives you that flexibility to spin up as many of these virtual networks as is allowed in your SDN, and provide that layer of security, I suppose, or not.
In this scenario, the application server in the top right and the endpoint in the top left are on the same network.
Yeah.
The application server can talk to the database via a different connectivity means, but the endpoint can't. So they could potentially even be on the same subnet, all three of those devices. But
absolutely,
there's some security mechanisms and constraints in there from so if your policy is allow application to talk to database and allow application to talk to endpoint, and then allow endpoint to talk to applications, and then after that it's a deny all.
Yeah,
that's what we're talking about here, right?
Exactly, and that that's across whatever that transport of your network is. So again, we're generalizing.
That replaces all the crazy access lists and on LAN switches and yeah.
Yeah, absolutely. I mean, to be fair, the configuration that's got to go onto those devices to make that happen is still going to be complex, right? This isn't stuff that can just happen. But of course, the configuration is automated, right? This is the important part here, that what we've done is put automated config in there to deliver the complexity. So it's not something that operationally the person who logs into the network to see why things aren't working typically won't have to worry about that, because these will be templated configurations. These will be automated and delivered from a central point.
That said, just before we move on from that, though, one of the things that was always a bit of a bugbear of mine, is that we don't want to, like you've just said there is a lot of work. So this is where you get people always talk about, oh, is my job going away and things like that. Is there a requirement for senior engineers and stuff? So the automated config as a result of like a senior engineer or consultant or whatever putting the graft in and the work in at the start to develop the policy, that then becomes, you know, a repeatable process for the operational teams or the project teams that want to reuse that functionality. So there is a lot of work that has to go in at the start to create the policy in line with the requirements. Yeah.
And I think that's exactly what we're trying to get to here, really, is that you can't just throw this stuff in. You can't just connect everything up and it'll just work. There's much more complexity in it. And if it's not designed properly, then you're going to struggle like hell to make it do the things you need it to do. So yes, you're right. I think what you'll find is the sort of the really basic operational stuff will gradually disappear, simply because the tooling that we'll have for visibility will be that much better. That will, you know, someone's not going to have to go logging into switches to check on ARP entries and MAC address tables and that sort of stuff. You know, those, while you need to understand that and understand the limits that are in that are put in place with an environment like this, and understand how it works, you won't need to have to be, you know, logging into switches manually and doing all that stuff. That stuff will be in that centralized visibility engine of some sort. So you'll have that visibility as well. Now, the other part to this is the control plane itself. Now, usually, and this is probably the defining feature of an SDN, is to have what typically referred to as the centralized control plane. It's one of those things. A lot of the state of the network will be still located in the switches and the routers that make up that network. You know, there's still all the underlay has to function, failover has to work, and that can only be done locally in the devices themselves. But the higher level state, the information about what those virtual networks look like, what's allowed onto them, what the security policy might look like, and so on, that state will sit in this central control plane. So more accurately, the control plane is distributed, okay, across that central point where the big decisions are made about how policy is implemented. That might be routing policy, that might be you know, application routing based on, you know, the performance of the underlay. That might be security policy. That might be any of the sort of big decisions about the configuration. They'll be made in that centralized control plane, but they will be pushed out to all of the other elements in the network for its function, and there will be still localized control plane there that you need to consider. Okay. So just very quickly, then, you can see that this list of things that we've got down here that the network guys always had to consider suddenly start to disappear. Things like layer 2 and spanning tree. We don't really care about that anymore because that's provided by the virtual networks. DCI, well, yeah, okay, there's still connectivity required between here, but it can be an underlay connectivity, and you whatever transport between the data centers. Routing protocols are now no longer of the concern of the people who are connecting devices to the network. These things are running under the hood. They're running down in the underlay, and in that automated config, or the control plane is looking after that centralized view. So that's no longer a worry. The resilience is just very simple. Again, in the underlay, Just think about having the no single points of failure and all that good stuff that we've always learned. The complexity of the configuration, we've just talked about that. That's dealt with by the automation engines. Documentation becomes simpler because really all you do is documenting policy and not having to document the detail of why configuration looks the way it does. Change control similarly becomes an interaction with the control plane, with the management, with the automation of the environment, not having to log into a load of boxes and make complex changes and upgrade this and change that all the way through. So it becomes a more predictable change control, potentially something you can do more easily and with less interruption. Security, we've already seen again that we've got that option of segmentation right the way across the network there, and being able to use policy at the edges of the network to provide the first layer of security. So that's covered. And minimizing the failure domains, well, we've already said, this network that sits underneath there can be segmented pretty much however, right down to every single point to point. It can be a complete layer 3 network. So it is doing a good job of minimizing the failure domains, because you can structure that network however you need to do that, and it doesn't have an impact on the services that you're running over the top. And so it's no longer an operational nightmare. Now that's a very long-winded way of getting to this point, but you can understand why I've done that, because hopefully as we move on into the next sections, you'll be able to see how those things are all relevant. I think at this point we might pause and pick the next section up in the next video. What do you think?
Yeah, sounds like a good idea.
Okay, well let's do that. So thanks for watching, everybody, and well, when you're ready, wind on to the next one.